Hello everybody. Welcome to the talk. We're going to go ahead and get started. I'm Jason Hamilton. I'm a chief architect for Wolters Kluwer North America Tax and Accounting. This is Bill Hilke, lead architect, and Sean Taylor, cloud architect. And today we're going to talk about two main scenarios in Azure Service Fabric that we've implemented. Particularly, we're going to talk about building large self-contained systems on cluster, and then we're also going to talk about using ASF as a containerization strategy and as a hosting strategy. So with that, let's go ahead and jump in. We'll give you a quick, brief overview of who Wolters Kluwer is and to level set the context and level set the problem space. And so with that, Wolters Kluwer is a global company. Its market cap is around $12 billion from a size perspective. And we essentially sell services and software and solutions to the professional vertical market. So think your doctor, your attorney, or your tax professional. It's very possible they know who Wolters Kluwer is, and it's very possible that they also may be a customer of Wolters Kluwer. So in particular, we're going to focus on a suite of products that we sell in our software division called CCH Access. And essentially, it's really where our Azure Service Fabric focus lies for this talk. And in summary, what Azure Service Fabric and CCH Access on Azure Service Fabric is, it's a suite of products that is an ecosystem from inception to the filing of the tax return for a large corporation. So think E&Y or mid to large organizations who would leverage that software. And that software is very highly transactional, and it also has a high bar for RTO and RPO. And the reason why that is because our customers essentially run their business on our software. So if they can't bill a client, or if they can't file a tax return, or if they can't calculate a tax return, that would be a substantial impact of their business. So we have to have that very high bar for our system. Okay, so now that we've given you a brief overview of who we are and what CCH Access is, let's talk about Azure Service Fabric and that software suite. There's a lot of data on this slide, but let's summarize it a little bit. We really had two main needs. We needed a distributed system platform that we could build these large self-contained systems on, and we also needed that platform to provide us a mechanism that we could simultaneously support our legacy systems that we have in place today in production, but also for the transformation efforts we're doing as well. And so we needed that platform to have both of those capabilities simultaneously. So when we talk about these self-contained systems, we're going to talk a little bit about one in particular, and it's a generic job system. And we needed to basically have a job system that could massively scale for the requirements on the screen. But think of multi-million jobs per day, think bursts of data per day at a terabyte level. And so from that perspective, we needed to have that dynamic scale associated with that job system on this distributed platform. And so when we were looking and investigating this, we also thought about the constructs of tenant isolation. And so classically, that's done in a data tier. And so we were looking to investigate to see if we could move it up the tier at the compute layer for more flexibility and more scalability for our customers for this job system. And so we were able to apply those principles with a POC, and we'll walk you through that POC. And essentially what we discovered that Azure Service Fabric met all of those base level requirements that allowed us to essentially focus on our intellectual property and take care of those base requirements and that base lifting for us, so we could then basically grow and build on top of that. So with that, I'm going to turn it over to Bill Hilke, who's going to talk a little bit more about the job system, and in particular, a couple key design constructs, as well as a demo that we did at the hackathon when we first started this journey about 18 to 24 months ago. With that, Bill?
Thank you. Thanks, Jason. So a little over a year ago, as Jason mentioned, we kind of started up a hackathon with Microsoft. And the goal was we wanted to take one of our most important systems that is essentially a monolithic in-tier design, runs in a data center, and move that into a microservice architecture, cloud-first system around Service Fabric as a first-class citizen, not really just shoehorned into Service Fabric, but designed around Service Fabric and everything that brings. So not to bury the lead, but it was successful. Obviously, that's why we're here today. And the application follows all the standard Service Fabric tropes. If you're familiar with them, we use partition services, stateful services. We use a lot of stateful data. All that stuff is fine. It's great. But there's two things in particular that we do that I think is pretty interesting that's not widely known or widely seen across any of the documentation. The first thing we do is what we call dynamic services in Service Fabric. And essentially, that's really just taking a Service Fabric service, registering it as a type, and instead of spinning that up as a default service, we don't do that. On demand, instead, we create those services as needed. Essentially, it's like a C# class definition, right? We instantiate a class instance, we instantiate a service instance, and it gets a unique service URI. So now we can route to a specific microservice running in its own code container, and it's not a partition service. We don't have to worry about data leakage, or we don't have to worry about noisy neighbor problems. This service has its own container, has its own service, and it can run wherever it needs to. And this is great for us, right? So now we don't have to worry about partitioning. We don't have to worry about those problems. We can basically have a service, we can route directly to it, and everything is great. One of the places we do this, and we do this everywhere, is what we call our queue microservice. And the reason why we have a queue microservice is we want to keep everything on cluster. We don't want to move off cluster for any reason unless absolutely necessary, because we want to let Service Fabric kind of maintain and handle our reliability and handle our load balancing. So we have our own queue microservice, and it does what you think it does. It basically queues jobs and facilitates those jobs off to other services to get executed. It's pretty simple. But this is not a partition service, right? It's not a service that we spin up ahead of time and a bunch of tenants go and connect to it. Instead, on demand, when tenants log in, we spin up this service. And now this service is available, tenants can use it, they can queue jobs. When they're all gone and they've all left, we can spin this service down, and now it's freeing up those resources. So in essence, we can basically elastically scale out and scale back in, not just the infrastructure, but we can also do it at the service level. So our resources in the cluster, we can reclaim and start using for other customers that are active. And if they're not active, we can take away. The other level where we do this at is what we call our data session microservice. Essentially, when you log into our system, you get a session, pretty common. But for us, we basically spin up your own unique microservice for that session. So it's not in a shared service. There's no data leakage. There's no noisy neighbor problems. You have your own microservice in your session. It's your own service instance. And it's at a very low level. It's a very small container. So in Service Fabric, that allows us to assign metrics to it. We can then assign dynamic metrics against it and let Service Fabric scale that microservice across the cluster very effectively. So instead of us having to load balance a very large chunky service, which would be a roll-up of a bunch of functionality, instead it's a unique instance of a service, and Service Fabric can scale that across the cluster or move it across the cluster and make sure we're fully utilizing all of our infrastructure. The other cool thing that I think we do in our system is what we call our tax calculation units. If you've ever used Elastic SQL and are familiar with DTUs, these are very similar. It's just a way for us to take the tenant isolation model at the data layer and move it into the compute layer. And as I talked about, when we have these microservice queues for tenants, essentially we can assign a tenant a bucket of resources. They can have 20 TCUs. And as a job comes in, it gets calculated a cost. And as long as you have not filled up your bucket in your tenant, we can basically go and facilitate that request. We can execute it. When they finish, we basically refund the bucket. In a way, it allows us to solve the noisy neighbor problem across the cluster and not have any issues there. So a tenant basically can't submit 10,000 jobs if they're not registered for such a high job load, and they can't overuse their basically pie of the cluster. So we can make sure that everyone gets a fair shot of the pie, no one gets overloaded, everyone's jobs can basically execute. So I'm going to show you guys real quick a demo. This is essentially the hackathon that we did. If I can find it here. This is essentially the hackathon that we did about a year ago or so. Are we get online here? We will attempt to get online and show said demo. Only problem with internet-based demos is you need the internet. Oh, and we are not showing on the screen either. I don't know how we
should just escape out of it, right?
Hold on. Okay, sorry, guys, 1 second. Let's see here. And I believe we just need to, nope. All right, guys, well, it looks like I won't be able to show you this demo. I apologize. But at the end of the slide, we'll show you a link to GitHub, which will show you the source code for the demo. You can go look at it yourself and kind of see what we did to make these kind of two concepts a reality. Let me get back. No, it's OK. And let us get back where we need to be for everybody. And I'm going to turn it over now to Sean Taylor, who is a colleague of mine, who is our cloud architect. He's going to talk about how we took containers, how we kind of transformed some of our existing system and started moving into Service Fabric as well. So thank you, Sean.
All right, thanks, Bill. Hi. So with Wolters Kluwer Tax and Accounting, we have an application suite called Access. Access has about 60 services. These services have tons of dependencies, tons of libraries that live on-premise. The task is to move these services along with their dependencies into the cloud. Of course, we chose Azure, right, we're at Build. So how do we go about doing this? So the task was, let's make sure that there are a few requirements that have to be met. First of all, we have to enable CI/CD. We have to have a robust CI/CD pipeline so that when developers are making changes and want to deploy through our SDLC lifecycle, those changes can be deployed often as necessary. We also need to have service compartmentalization, service isolation. So the premise is when you're deploying and creating services and deploying to an environment, you want to make sure those services don't interact and have any version conflicts, right? So we know our developers are deploying assemblies. These assemblies sometimes have different versions, and these versions can sometimes conflict with each other if they're on the same host. With containerization, we don't have to worry about that anymore. We also want to make sure that we have portability. So our services run in a Windows environment, IaaS services, and we want to make sure that we can pick up our services in a bundle, all of the dependencies, and move those dependencies into an Azure environment. In any environment that we choose. Again, we're using a Windows Server container environment, so we decided to move into Windows Server. Now, after we move our services into our Azure environment, how do we orchestrate our services? We need to be able to deploy into our environment, into a orchestration setup, such as ASF. ASF gives us containerization. ASF gives us orchestration, sorry, out of the box. So with orchestration, we decided, let's just use ASF because we're already doing that. As Bill mentioned before, we're using a Service Fabric today in our environment. So now that we have CI/CD, we have portability, we have service isolation, we have orchestration, do we have security? Well, our containers definitely have security, right? As mentioned in the keynote this morning, services in one container cannot peek into another container. So we definitely have security involved. I wanted to show you how to get this via demo.
If you just extend your monitor, it should work, right? So just extend monitor. Go into settings.
I'm sorry, give us 1 second.
Scroll down. And then just a duplicate. Instead of extend, duplicate.
Okay.
And then hit apply. There you go. Keep changing.
So what we wanted to do is give you a demo of how this is going to work. But we're having issues with the network. Oh, am I? Okay. Let's see.
Hopefully.
I am. So we needed to create an Azure Container Registry. The Azure Container Registry, oh, I missed one point. So we're using Docker. Docker is native to first-class citizen of Azure now, right? So we know we can use Docker as our container strategy, container vendor. So now that we have Docker as our container vendor, we need a place to keep our Docker images. To do that, we have to create an Azure Container Registry. So we go into the portal, and we open up and create an Azure Container Registry. And after we have the container registry, we then go into our Visual Studio solution. And now we can create our Docker file. So you also saw this morning that in 2017, you can right-click on Visual Studio and you can say, Dockerize add Docker support to my solution. And once we do that, you'll add a Docker file here to your solution. This Docker file is going to bootstrap your environment as well as deploy all your services that you have defined. So it sets up your environment and you tell it what services and dependencies you need to set your environment up with. Once you have your Docker file created, you will also need a Service Fabric containers project. This project is going to be the project that allows you to deploy your Docker images to the ASF Fabric cluster. So you go in there and you create your references to your container registry, and you also had a reference in your application manifest to the image that you want to deploy. Now, once we have, okay. All right. So this is our container registry. And this points to the container registry that we showed, I mentioned earlier. And then your service manifest, we have reference to the image that we want to deploy. So image name is here. All right, so now that we have everything set up in our solution, we want to be able to go to our CI pipeline. So we go into VSTS, and in VSTS, the first thing we have to do is we need a build that's going to support Docker. So we have to enable our VSTS repo to support the Docker extension. So we go into Marketplace, and we find a Docker integration, we run install, and it's going to add Docker support to VSTS. Now you can go, oh great, it's coming up. Now we can go and create a build, a CI build. Once we have a CI build created, once we have our CI build created, what we need to do is add a Docker step. So we have our solution build as normal. Then we have a Docker step that points to our Docker, our container registry. This is going to push our Docker image into our registry. Then we have another step. This is going to build our image. Then the second step is going to push that image into our Docker registry. So once we have that defined, then the last step is just to create a release. Right, so we have a release step, and the release step is just adding continuous deployment. What we need to do is create our access to our Service Fabric cluster. And when we have the release step to Service Fabric cluster, once we hit deploy, it's going to, here it is, our container cluster. Once we hit deploy, it's going to release and publish that Docker image into our Service Fabric container cluster, and then spin up the image. And so this is basically the general synopsis of how you can bundle your services from on-prem, move it into Docker and Service Fabric, and use containerization strategy with your solution today. All right, I think that's it. If you guys have any questions, here's our contact information. Here we go. Feel free to contact us after our demo, after our presentation, and we'll answer any questions we have for you.
Yes.
Hmm?